So now that we have proved Wick's theorem for general n, let us show what happens when we sandwich them between free vacuum. So we want to see what this is. But we're just going to use our usual shorthand notation and write the time-ordered product using Wick's theorem to be normal ordered product of phi 1 dot dot phi n, and then all possible contractions. And then like this. Now, in the all possible contractions, there will be term, or there may be term, where we don't have any free operator, that is, all the operators have been contracted. So it's only those terms that are going to survive by sandwiching it between the two vacuum. And that's because each of these operators, the free operators which are not contracted, they have both creation operator and annihilation operator, meaning that phi will have, say, phi plus and phi minus. And if I apply phi to the vacuum, then from both sides, then we will have phi plus plus phi minus. So this thing has a creation annihilation operator. So this thing applying on this vacuum will give me 0, and this thing has a creation operator, so this guy acting on this thing will give me 0, because if you remember this thing, if I take the Hermitian conjugate, this is nothing but this, and this is 0. So only the terms that have all the operators contracted here will survive. So let me demonstrate this with an example. And the example is the simple example where we have the time-ordered product of two operators. Then, of course, what we have is we have the normal ordered product of these two operators. And then we have the contraction, this whole thing. But then if I look at this is normal ordered, and therefore it either has a annihilation operator on the right, or it has a term where both of the operators are creation operators. But if both of the operators are creation operators, then that will annihilate this term. So either way, this is going to give me 0, and the only term that will survive is this term. The contraction between phi 1 and phi 2 is a function. It's not an operator, so we can pull this out of the inner product, and this is just 1. So therefore, this is going to be equal to the Feynman propagator. Similarly, if I take the time-ordered product of three operators, because there will always be a term in which one of the operators will be uncontracted, this will be identically 0. On the other hand, if I take the time-ordered product of four operators, then only the term where all the operators are contracted will be non-zero, and therefore the result of this would be the Feynman propagator between x1 and x2 times df x3 minus x4 plus df x1 minus x3 df x2 minus x4 plus df x1 minus x4 times df x2 minus x3. So this is what the vacuum expectation value does.